Fine. I went router 1. I hope this is having already the IP addresses. Show IP interface brief. If you notice here, I have two loopback, and I also have an IP address on the interface. But I do not want ISIs, which is already running. If you wish to remove the routing protocols, if you wish to remove all the routing protocols, there is a command, no IP routing. For example, before I put the no IP routing, let me show you. Show IP protocol. You see there is already ISIS running. But after I put this command, you see, no IP routing. After I put this command, you will find no routing protocols running. And you need to put the command back, IP routing. You see, there is no ISIS. Not only ISIS, you may have BGP or OSP, whatever. It gets removed if you put no IP routing. All the routing protocol will get removed because you are saying no IP routing. This is not a routing device. If it is not a routing device, then why there is need for a routing protocol? That is why it gets removed. Let me also remove ISIS from router 2. No IP routing. IP routing. Remove this and put it back. Now you should not see any protocol. Show IP protocol. There is nothing. There's nothing. Similarly, I'll do it on R3. No IP routing and IP routing. Got it. Right, we are now going to put ISIs again. You see, I'm starting with router 1. Configuration is very simple. Router ISIs. If you give process ID, no problem. If you don't give also, no problem. You see, I don't give a process ID. If you want to give also, you can give. Let me remove this. Router ISIS London. So what do you understand? A process ID can be a name also. It does not be a number. Can even be a name. I want to remove this. I want to go with my router ISIS. Router ISIS followed by net. See, this net address can be of 13 byte to 20 byte. .0010 or 0A. A means what? 10. This is area ID 10, and this is simply 47, a private area. Even if you don't put 47 dot, it is okay. Now this portion can be just 1 byte, or it can go up to 13 byte. 13 byte, 1 byte or 13 byte. As of now, how many bytes we are using? 1, 2, 3 bytes only, out of 30. Now followed by 6 bytes of system ID. For router 1, I want to give, this is 2 byte, 4 byte, 6 byte. This is system ID. Every router within an area should have unique system ID, and I give 00. This 00 represents N selector. This 00 says ISIS is an this ISIS is an IPv4 modified version of IPv4. This ISIS is a IPv4 ISIS. That's what the 00 means. Okay, we have configured a net ID. We have configured a net ID. Now you need to go to interface and enable ISIS. IP router ISIS. See here I did not give process ID. If you don't give process ID, here also don't give. Interface loopback 1 IP router ISIS. Interface F00 IP router ISIS. Done. Right now we are running ISIS on this router, and it is running on one physical and two logical interface. The verification command is this: show CLNS interfaces. Okay, interface. You can see here CLNS meaning ISIS is running on loopback 1 and on loopback 0, and it is not running on these interfaces, but it is running on one physical interface up here, which is F00. So we can see ISI is running on F00 and loopback 0 and loopback 1. And the routing protocol that is running here is ISIS. Now, the default metric is 10. But in my previous class, I have configured as 20, I think. That's why it is showing 20. It should show 10. So what I'll do is, I'll go to the interface and check show run interface F0/0. I want to check, look at this. I'll remove this so that it will go back to the default. I removed it. Now let us go back to that CLNS interface. Remember this show command. Show commands are very important for troubleshooting. Show CLNS interfaces. Go up, and now you can see level 1 metric is 10. I told you, any interface, any bandwidth, the cost is only 10. ISI's cost is always 10. But you can configure manually. You can configure it manually. You can remove it as I showed you. You can remove it from the interface by putting no. About the priority, we'll talk later. The default priority is 64. That is for DR election. right? The one with the higher priority becomes the this. What is this? Designated intermediate system. In OSPF, we used to call it as DR. Here we call it as this. Yeah, we call it as this here. Designated intermediate system. Now, which one is a disk? Router 1 is a disk. How do I know? Because I see R1.01. It is not showing R2.01. If the circuit ID is R2.01, then router 2 is then this designated intermediate system. We'll see those things in detail later. Now going down here, you don't run IPv6, so no worries. Hello packets are sent every 5 seconds. Every 5 seconds, hello packets are sent. Same like EIGRP. Now let us capture one hello packet. Before that, why is this R1 a disk? Why is R1 a disk? Because we have not yet configured R2 with ISIs. If you configure R2, R2 will become a disk. After that, if you come here and see, it will be R2.01, not R1. The one with the bigger router ID, bigger MAC address. Here it is bigger MAC address, not the router ID, the MAC address. First, it will check the priority. The default priority is 64. If both sides if it has got 64, then it is going to compare the MAC address. The one with the bigger MAC address becomes the disk. Okay, let us now verify using capture. I want to show you the hello packets of R1. Okay, ISI is hello. You see, it is not even layer 3. Do you see any layer 3 here? No. Ethernet only. It's layer 2. And you see the system ID that I gave there. You remember on the IO, on the command line, when I configured, I put, after area ID, I put system ID as 11111. This is the system ID. System ID is always 6 byte. And it should be, I always, think from right to left. 00, that is 1 byte of N select. This is always 00 for IPv4 ISIs. And then next to 6 byte is system ID. And then 1 byte to 13 byte is area ID. Okay, this is mandate. This should be 6 byte. And this should be 1 byte. Okay. Now let's go back to our Wireshark. You see the timers, it is 5 and 30. Whole timers 30, don't forget. And the priority is 64, default, system ID. Designated IS is the one with this system ID. All right, the one with this system ID. We have not yet configured R2. That is why it is like this. Area ID. Area is 10. You see, area 10. This is one of the IP address on the physical interface. All right, so these are the informations that Hello Packets need. Now, let me go to router 2 and configure ISIS. Router ISIS net 47.00 dot sorry 000A dot. That is all. Now go to the interface loopback 0 IP router ISIS interface F00 interface F01. Okay. Okay. Now what are you going to do? I'm going to take you back to R1 and type this command once again. And I would like to see, look at this, it is changed. Now, who is that? This, the one with the host name R2, the one with the host name R2. Okay. Right. Now, I think I made a mistake. Hello packets are not sent every 5 seconds, it is 10 seconds. Same like OSPF. And the dead timer is 30. That we saw. Dead time is 30, correct? Dead time is 30. But the hello time is not 5 seconds, it is 10 seconds. Now, let me pick another packet. You see this packet. It says this is 22222. Whoever has got 22222, that is the this. And this is who is sending? Router 1 is sending. Okay. It's a L1 hello. I also see an L2 hello. Why it is L2 hello, you tell me? Why it is sending L2 hello? Because by default, both L1 and L2, by default, both L1 and L2 adjacency will be formed. Yeah, by default, both L1 and L2. Let's go and see that in R1. Show ISIS neighbor. I do see only L1, but the hellos are sent every of now and then, both L1 and L2. How is that possible? Actually, R1 is not sending. R2 is sending that. Why R1 is not sending? Let's see. Show one section outer ISIS. In the previous class, I have made this mistake. I did not remove it. No, this is very important. I thought no IP routing will remove it. Yeah, it removed it, but this configuration is still there. This is what confused. This is what confused our router. So what I'll do is I will now check show ISIS neighbor. No, I'm going to do what? Interface F00 shutdown. Now I should see L1 and L2. R2 is both L1 and L2. Show one section router ISIS. Yeah, in here we have not mentioned L1 or L2. It is both. It's the same thing, but I think I have to remove this. It's an olden days configuration, the previous batch configuration. Remove this. This will confuse actually. Interface F00, I'm going to shut down. Also on R1, I'm going to shut down. And now I'll bring it up. Let's now check the neighbor. Show ISIS neighbor. Oh no, why it is again L1 only? Though it is same area, it will form both L1 and L2. Something is. It is good that it forms only L1, but by default it should do L1 and L2. I'm just trying to check. Maybe I need to check under the interface. There may be something under the interface. Show run interface F00. You see, I found it. I have put also on the interface saying it should be only L1. This is all magic I did in previous class. Sorry for that. If I would have taken a fresh topology, you would have not faced this problems. Now, I'm going to shut down once the interface to have a fresh start. Now you will see both L1 and L2 adjacents, which is default. Show ISIS neighbor. You see, this is default. And you see which one is the biggest. Router 2 is biggest. So router 2 is the this. Router 2 is the this. You can see here. Who is the this? Down. The dis is 22222. The router with this system ID is the dis. Even router 1 is also saying, this is router 1 saying my dis is 22222. Complete sequence number protocol data unit. This is also the packet that has been shared by ISS. All right. So we see here there are two adjacency, L1 and L2. See, between multiple areas, if you are forming neighbor, for example, router 2 and router 3, you must have L2. But with router 1, L1 adjacency itself is enough. You can suppress L2, but not now. We will do it later. Let it be two sessions, two neighbor sessions between each router. Now I'm going to router 2. Show ISI's neighbor. It says I myself is the this. You see the whole time is 30, 25, 23, 22, 29. You see, after 22 comes 29. What do you understand from this? Every 10 seconds, the hello packets are coming. And the dead time is 30 seconds. 10 and 30, please understand. OSPF is 10 and 40. ISIS is 10 and 30. And now, if you open ISI's hello packet, it is not a layer 3 packet, it is a layer 2 packet, and it is sent to this ISIS multicast address C2. Yeah, this MAC address is same always. It's ISIS. It is never changing. Only the last number changes. For level 2, it is 15 in the last. For level 1, it is 14 in the last. That is the only change. The remaining part is a standard MAC address for ISIS. 0180C200. This is the address to which it is sending to form neighbor. Hello packets are sent to this multiple. Again, for level 1, it is 14. For level 2, it is 15. I'm on router 3. I want to go check all the interfaces before I do show run interface F00. Is there any additional configuration? No. Show run section router ISS. Yeah, I have to remove this. I will remove this. I don't know when I was doing all this summarization in the. All right. On router 3, show IP protocol. No routing protocol now. I'll enable ISS. Router ISIS net. Some of you tell me, or any one of you, any volunteers, I want to give net ID in router 3. Guide me. What should I type? Why no one is talking? Okay. .57.0020. Okay. Not 3.3.3.3, that's all. What is next? Tell me next. Go to the interface. Okay, going to the interface, loopback 0, IP, router, ISIS. That's the syntax. And then go to the physical interface, F00. You can also use range command. If you want to do on the multiple interface in one go, you can say interface range F0/0-1 IP router ISIS. So in one go, we are able to configure on multiple interface. Okay, next. Let us move on to router 4 now. Show ISIS interface. There is no command. That's why I was using CLNS interface. Show ISIS all. What does it mean all? Routing information base, SPF log, topology. Okay, it shows the MAC address of the neighbor device. Simply means MAC address. Okay, the metric is 20. Oh yeah, for router 3 it is 20, no? R1 metric will be 20. 2 links. That's right. And the next stop is R2. This looks good. R4 is L1, same area. I'm in R3. And level 2, router 1 is level 2, other area. Router 2 is also level 2, other area. Okay. And we also have L2 adjacency with R4. That's what shows like this. So let's go here on R4, show ISIS neighbor. You can see neighbor. Now let's go to router 1 and check the routing table. Show IP route. What do you see here? We see, okay, let me type ISIS. We see here L1 means local area network. L2 means coming from other area. You remember we have two adjacency on R1, both L1 and L2. That is why you are able to see these routes. If I make R1 as only L1, instead of these routes, you will have default route. See, right now I'm able to ping 4.4.4.4.4. Source 1.1. I'm able to ping. Now I'll make it as L1 only. How? I'll go to the interface and say ISIS circuit type level 1. Okay. Now, this level 2 adjacency, I said I want only level 1. So level 2 adjacency will go now. Show ISIS neighbor. Now I have only L1. Check the routing table now. Show IP route ISS. You see, you have a default route to reach 4444333 all other areas. Now you see, I'm able to ping this. How? Because of the default. So we did not configure any stub. In OSPF to achieve this, we used to configure stub. In ISIS, you don't need to configure stub. If you remove L2 on all the routers where you see only same area member as a neighbor, then automatically your routing table will be small. What is the command I used? Show run, let me show you. This is the command. ISISOQ type level 1. See, router 2 will have both. Show ISIS, show IP route ISIS. Router 2 will have both because it's in the border. It should have L2 to talk to other area and learn the other area routes, and L1 to talk to the same area member and learn local area network. But it is not necessary in R1 to have L1 and L2. You simply have L1 local area networks. For the rest, you can have a default route given by your closest L1, L2 router. If you check here, there will be two databases. You see, show ISIS database. You will have two databases here. One is the L1 database with the L1 members, L2 database with other area members. Router 2 is talking to other area. Right, next. This will disappear when this becomes 0. You see, it's going down. It's an old state. Now, where are we? We cannot make this one as L1 because it's in that transit. Yesterday I told you. If it is in transit, you cannot make like that. Now I'll go to router 5. And 6. Assume I don't have router 7, then R6 will have only L2. You don't need to have L1. You can say L2 only. Assume that I don't have router 7. Assume that I don't have any router in area 30 except router 6. Then you can make it as L2 only. L2 is very important to form neighbor with other area. L1 cannot form neighbor with other area. Okay, R5, R4 is done. R5. I think this is already configured. Show ISS neighbor. Yeah, it is already configured. You know how to configure. I can show you once. Show one section router ISS. This is how we configure. You put this one and then you put this command on all interface. Each interface, you put IP router ISS. Now let's go to router 6 and verify. Show ISS neighbor. You can see I have only L2 adjacency with router 5 because it's a different area. Right now, if I go to R1, I can ping 6.6.6.6, which is the router ID of R6. You can also trace route and see. But there is no route. There is no route 6.6.6.6, but you have a default route to reach all the networks in every area. Now let's move on to the last router, router 7. This is also already configured. I'm just going to show you that you can have only L1 here. Show ISIS neighbor. I can suppress this. So right now, show IP route ISIS. You have all other area root as well. But when I go here and say, I can also say globally, listen, I'm not going this time interface. I'm saying this whole router is L1. Router ISIS, IS type, level 1. That's it. Let us check now show IP protocol. You can see ISIS is running, but when you check neighbor, show ISIS neighbor, you have only L1. It will come. It will come. Yeah, see? Only L1 has come. Let us go verify now the routing table. I should see only a default route. Yeah, I'm able to ping now with the default route. We are able to ping from end to end. Oh no, 7777. Router 7, no? You see, we are able to ping. Right? So